A warm welcome to all of you. Today, we will discuss about paradigms of machine learning. Paradigms of machine learning means the types of machine learning or the classification of machine learning. Machine learning paradigms define how a system learns from data, depending on whether data contains labels, partial labels, or feedback signals. The learning strategy changes. Broadly, machine learning is divided into four paradigms: supervised machine learning, unsupervised machine learning, semi-supervised machine learning, and reinforcement learning. Each paradigm solves different types of problems and is chosen based on data availability and problem complexity. Understanding these paradigms helps us select the right algorithm for real world applications. Now, the first one is supervised machine learning. Supervised machine learning uses a dataset that contains both input data and correct output labels. Each training example consists of features and a known label. The model learns a mapping between features and labels. Errors are calculated by comparing predicted output with actual labels. This paradigm is widely used for classification and regression problems. Examples: in student result prediction, features are attendance of the student and internal marks of the student, and the label is the final grade, whether the student secured A grade or B grade or C grade or D grade. And in some other case, whether the student is fail or pass. In email spam detection, features are email content and sender information, and the label is whether the email is belongs to spam email or not a spam. In supervised learning, everyday instance is associated with a known output label. The learning process involves mapping input features to the correct output. The model continuously compares predicted results with actual labels and adjusts itself to minimize errors. Because of this feedback mechanism, supervised machine learning achieves high accuracy when sufficient labeled data is available. It is mainly used for classification problems, discrete outputs, and regression problems, continuous outputs. There are few examples for supervised machine learning. Student result prediction. In student result prediction, there are two things will come into the picture: the list of features and a label. The list of features in student results prediction: attendance, internal marks, and classroom performance, like F1, F2, and F3. And the label is final grade, whether student will get A grade, B grade, C grade, or D grade. And the second example, email spam detection. In email spam detection, features are email, text, and sender detail. Suppose the email text can contain, if at all, if a email, if it is belongs to spam or not a spam. Suppose email text consists of lottery, discount, hurry up, limited time offer. If at all, if is there any these kind of features, then automatically algorithm throws this kind of email to spam box. So that's how the supervised machine learning will perform. The next example, house price prediction. In house price prediction, the features are area of the house, square feet, number of rooms in a house, location of the house, right? These things decides the outcome variable or the target variable house price. Similarly, in medical diagnosis, features are symptoms, test results, and the outcome variable is disease present or not, whether the person is diabetic or not. These two things will fall under labels of for that particular data. Even in credit card risk assessment, the list of features include income of the person, loan history of the person, credit score, and the outcome variable, the target variable, is having two labels, whether the loan is approved or rejected. So in supervised machine learning, the outcome variable specifically will have a labels. The next one is unsupervised machine learning. Unsupervised machine learning uses data that does not contain output labels. Only input features are provided to the model. The system tries to find hidden patterns or structures in the data. No error correction is performed using labels. This paradigm is mainly used for clustering and association analysis. Example, in customer segmentation, features are purchase history and browsing behavior, and no labels are given. In market basket analysis, features are purchased items in transactions, and no output labels are available. In unsupervised machine learning, the data does not contain output labels. The model receives only input features and tries to discover hidden patterns and structures within the data. Since no correct output is provided, there is no direct error correction. The focus is on finding similarities, groups, or relationships among data points. Unsupervised learning is widely used for clustering, association, and dimensionality reduction. Here are the list of examples for this. In customer segmentation, there are certain features like purchase behavior, browsing patterns, and these things facilitate us to segment the customer related data into different groups like high income customers, middle income customers, and low income customers. Even in market basket analysis, also, there are some features like items bought together and social network analysis. There are some features like user connections and interactions and document clustering. In document clustering example, there are some features word frequency in documents and anomaly detection. There are some features in anomaly detection, network traffic data to identify unusual behavior of the people. So these all things will fall under unsupervised machine learning. In unsupervised machine learning, we will not have any target variable and associated labels. The next one is semi-supervised machine learning algorithm. Semi-supervised machine learning uses both labeled as well as unlabeled data. A small portion of data contains labels, while most data is unlabeled. Labeled data guides the learning process. Unlabeled data helps to improve model generalization. This paradigm reduces labeling cost and improve accuracy. Example, in image classification, features are image pixels, labels, or object names for a few images, and most images are unlabeled. In speech recognition, features are audio signals, labels are text transcripts for limited samples, and remaining data is unlabeled. In semi-supervised machine learning is used when only a small portion of data is labeled and remaining data is unlabeled. Labeling data manually is costly and time consuming, especially for large data sets. In this paradigm, labeled data provides initial guidance to the model. Unlabeled data helps the model learn data distribution and improve generalization. Semi-supervised machine learning strikes a balance between accuracy and labeling cost. There are few examples of semi-supervised machine learning algorithm. The first one is image classification. In image classification, there are some features related to images. As example, image pixels and the outcome variable, object names for a few images, speech recognition, audio signals, text transcripts for limited samples. In the example of face recognition system, the features are facial images and the outcome labels are names for only a few faces. In the medical image analysis, the features are MRI or X-ray images and the labels are diagnosis for limited cases. In the example of text classification, features are document text and the labels are categories for few documents. So this is what about semi-supervised machine learning algorithm. The semi-supervised machine learning algorithm, it is both a combination of labeled data and unlabeled data. So the next one is reinforcement learning. Reinforcement learning does not use labeled input to output pairs. The model learns by interacting with an environment. Actions are evaluated using rewards and penalties. The goal is to maximize cumulative reward over time. Learning happens through trial and error basis. So in reinforcement learning, learning will happen on the basis of trial and error basis guided by rewards and penalties. In game playing, features are game states, labels are not given, and feedback is provided as rewards or penalties. In robot navigation, features are sensor readings and position data, and labels are replaced by reward signals. Reinforcement learning is inspired by how humans and animals learn from experiences. The system called an agent, which interacts with an environment by performing actions. Each action results in a reward or penalty instead of a labeled output. The agent learns a strategy known as a policy to maximize cumulative reward over time. This paradigm is best suited for decision making and control problems. There are few examples of this reinforcement learning game playing. Example chess game. Rewards for winning moves, penalties for losing moves. Robot navigation. Rewards for reaching destination safely and being occurred by accidents, penalties. Autonomous vehicles. Rewards for safe driving, penalties for collisions. Recommendation systems, rewards based on user clicks or engagements. And one more example, industrial controlled systems, rewards for efficient energy usage and performance.